Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Let's see this problem. We are given an array and we have to find a pair with maximum difference such that j is greater than I, and we have to calculate maximum difference by subtracting ai from aj. When you see this problem for the very first time, it may seem difficult to understand. So let me make this problem simple for you. Okay. So now let's understand this problem with some examples. So let's see the first example. Here we have array with elements 2, 3, 1, 10, 5 and 4. Okay. And what is given in the problem? We have to find pair. Okay. So we have to consider two elements here. So if we consider two elements, let's say 2 and 3, and calculate the difference of it, you get 3 minus 2 is 1, right? Because we have to calculate difference always using this expression a of j minus a of I, means we have to subtract first element from second element. Okay, so 2 minus 3 is 1, 3 minus 2 is 1. Okay, 1 minus 3 is minus 2, 10 minus 1 is 9, 5 minus 10 is minus 5, 4 minus 5 is minus 5. So if you consider all the pairs, you are never going to get maximum difference more than 9. Okay, because 10 minus 1 is 9. So this pair gives us the maximum difference. And if you consider other pairs other than these two pairs, you always get maximum difference less than 9. Okay, let's see the next example. Here in this example, all the numbers are arranged in increasing order. Okay, you can see that 1, 2, 3, 4, 5. So when numbers are arranged in increasing order, you always get a maximum difference when you subtract last number from the first number. Okay, so 5 minus 1 is 4. So other than this pair, you always get number that is lesser than this number. Okay, now let's see the next example. In next example, these numbers are arranged in decreasing order. You can see that 5, 4, 3, 2, 1. So in this type of case, you always going to get a number difference in negative numbers, and the maximum negative number you get by subtracting 5 from 4. Okay, and if you consider any other pair other than this, you always get number smaller than minus 2. You get minus 3, minus 4, minus 5, or minus 1, minus 2, like that. Okay, so now I hope that you understand this problem really well, that we have to find pair with the maximum difference, and we have to follow this condition that j is always greater than 1, and we have to calculate maximum difference by subtracting a of I from a of j. Okay, so now let's pause the video and think about an algorithm to solve this problem. Alright, by now I hope that you would have written at least basic program to solve this problem. So let's see the brute force approach to solve this problem. Here is the idea. We have this array 2, 3, 1, 10, 5, 4. And the constant is j should always be greater than I. It means whatever number we pick, the index of that number is always be greater than the second number. And we have to always calculate difference by subtracting a of I from a of j. Okay. So in this approach, what we are doing, we are going to first create a variable, and in this variable we are going to store minimum value, and we get this minimum value from integer class. And then we pick I by traversing this array from 0 to n minus 1. So in this way we pick the one element at a time, and that is going to be our I. And for each I, what we are going to do, we are going to find j. And how we are going to find j? Let's say our I is 2, then we are going to find j by traversing to the right of I till n minus 1. And then in each iteration we are going to calculate the maximum difference. Okay, how we are going to calculate maximum difference? First we find the normal difference, and then we compare with this current maximum. If we get new difference is maximum than this current maximum, then we simply update this current maximum to that difference. Okay, and we have to follow this process for all the iteration. So this is the simple basic idea to solve this problem. Now let's see the implementation of this basic approach. So here you can see the implementation of this basic approach. Here we have a function find pair with maximum difference, and this function is taking integer array. Okay, in the first statement we are taking the length of the array, and in second statement we are initializing current maximum with the minimum value, and we are taking the minimum value of integer. Okay, next we are running a loop from 0 to less than n, and in each iteration we are going to find j for I, and we are running this loop from I plus 1 till less than n. Why I plus 1? Because if I is 1, then we have to find j to the right of I, because we have a constraint here that j should always be greater than I. Okay, and then in each iteration we first calculating the difference arrj minus arri, and then we are checking if the difference we are getting is maximum or not. So here we are taking help of math.maximum function. This function checks what is the maximum between current max and max. It figure out the maximum number and it set that number to current maximum variable. Okay, and after completing this loop we are returning the value of current maximum variable. Okay, so this is the implementation. Now let's quickly dry run this code and see how it works. So we have this array 2 3 1 10 5 4, and we are initializing current maximum to minimum value, that is the integer dot minimum value, and these are the indexes of all the elements present in the array. Okay, so when we run this program, our loop begins. In first iteration the value of I is 0, and the element present at index 0 is 2. Okay, so we have to find now j for number 2. So we traverse to the right of 2 and check for all the elements. Okay, so 3 minus 2 is 1, 1 minus 2 is minus 1, 10 minus 2 is 8, 5 minus 2 is 3, and 4 minus 2 is 2. So among all the numbers we get maximum as 8. So we update our current maximum to 8. Okay, then we move to next iteration. In next iteration our I becomes 1. Element present at index 1 is 3. Now we go to the right of 3 and find difference for all the number. 1 minus 3 is minus 2, 10 minus 3 is 7, 5 minus 3 is 2, and 4 minus 3 is 1. So among all the numbers we do not find the maximum number, so our maximum remains the same as 8. Okay, moving to next iteration. In next iteration our I becomes 2, and element present at index 2 is 1. So we go to the right of 1 till 4 and find difference with all the elements. 10 minus 1 is 9, 5 minus 1 is 4, and 4 minus 1 is 3. So now you can see that we get our new maximum, that is 9. So we set the current maximum to 9, and this loop continues for the next two elements 5 and 4. But in those cases also we will never going to get number greater than 9. So the output of this input is going to be 9, that is the maximum number we get by subtracting two numbers, that is 10 and 1. Okay, so far so clear. Now talking about the time complexity, we are running two loops, and these two loops are nested loops. Outer loop is running n times and inner loop is running n times. So we can say that the time complexity of this solution is going to be big of n square, because whenever we have nested loops we simply multiply the time taken by both the loops. Okay, now talking about the space complexity, in this function we are not using any extra space other than the input array and some of the variables. So the space complexity of this solution comes out to be theta of 1. So to solve this problem we are taking big of n square time and theta of 1 space. So far so clear. But this is the same question we ask ourselves in every problem, that can we do it better? Can we have better approach to solve this problem? Can we reduce this time complexity from n square to n? Because this is a quadratic order of growth. It would be great if we bring this time complexity from n square to n. So do one thing, just observe the given array and think about the approach that can solve this problem in big of n time. If you observe this array carefully, then I am sure that you are definitely going to get some idea that can solve this problem in big of n time. So alright, let's see the efficient approach to solve this problem. So the array is given as 3, 2, 1, 10, 5, 4. So we have to calculate the difference by subtracting a of I from a of j, and the condition is j should always be greater than I. So here we have observations to be made. So let's say we have two variables a and b, and if I ask you that suggest me two numbers so that when I subtract a from b, I get the maximum difference. So what would you suggest in this case? So obviously you are going to suggest that take the a as the smallest number and b as the largest number. So when you do like this, you are always going to get maximum difference, correct? So this is the fact that if we want maximum difference, then our second number is always going to be maximum and the first number is always going to be minimum. Okay, this is how we get the maximum difference. So considering this array and j should be always greater than I, our a is always going to be the smallest element among all the elements, right? And our b is always going to be the largest element among all the elements, correct? What we do, so what we are going to do in this approach, we consider all the element as the largest element, okay? And we simply going to keep track of the smallest element, and whenever we find new smallest element, we simply going to update our smallest element, and with all the smallest element we are going to find the difference, okay? And if the difference is maximum, we update our maximum variable, okay? We are going to, if the difference is maximum, we are going to update our current maximum, okay? So let's understand this with example. So let's say we have two elements, okay? We need two elements because j is greater than I, so we cannot do this with only one element. So in anyhow we need at least two elements. So we are assuming that the smallest element is 2, okay? And the largest element is 3. We are assuming that because we need at least two elements to solve this problem. So first we are going to find the difference, and difference of 3 and 2 is 1, okay? So maximum so far as we get is 1, so we set our maximum to 1, and then we compare that the new number we are traversing is smaller or greater than the smallest number. So we compare 2 and 3. So after comparing 2 and 3, we get to know that 2 is the smallest so far. So we keep the smallest as 2 only. Now if we get new number in future, okay, that is 10. So currently the smallest number is 2 and we are considering this number as largest. So first we are going to find the difference of two numbers, that is 10 minus 2 is 8. Now you can see that before our maximum is 1, now we are getting maximum as 8. So what we are going to do? So this time we are going to update our maximum to 8, okay? And this is the maximum difference we got so far by subtracting two elements. And then we compare that the current element is smaller or greater than the smallest element. And you can see that in these two numbers, 2 is the smallest. So we keep our smallest as it is, okay? So this is the simple approach we are going to follow to solve this problem. So now let's see the implementation of this simple approach. So here is the implementation of this efficient approach. In this function, we are taking arrays input. In first line, we are taking length of the array. In second line, we are assuming that the first element is the smallest element, right? Okay. In third line, we are storing value of a minimum integer to the current maximum variable, okay? And then we are running loop from 1 to less than n, okay? Why we are running from 1? Because if we consider that 2 is the smallest, then we have to find second number to the right of it, okay? That is going to be the largest number. And then we are first calculating the difference of ai minus smallest, means number 1 element is 3, 3 minus 2 is going to be 3 minus 2 is 1, okay? Then after getting difference, we are finding the maximum between current max and the difference. If we get new current max, then we simply update the current max to that new element, okay? So this function is going to find the maximum between current max and the difference. If we get the new maximum, then we are simply going to update our current max to that number, okay? And in next line, we are again finding smallest number by comparing the smallest with the number we are traversing. For example, if the number is 3, then we are simply comparing 3 with 2. But in 3 and 2, 2 is the smallest. So this math.minimum function is going to find smallest between these two numbers. So this function finds the smallest number and store it into the smallest variable. And after loop gets completed, we are returning the value of current max. So now let's quickly try run this code and see how it works. So we have array 2, 3, 1, 10, 5, 4. These are the indexes of the array. Here we are assuming that the smallest number is the first element. It means 2. And we are initializing current max to minimum value of the integer. Okay. Our loop begins and the initial value of I is 1 because we are starting from 1. So element present at index 1 is 3. So we are going to find the difference by subtracting 3 from the smallest element, that is 2. 3 minus 2 is 1. So 1 is the maximum difference so far. So we update our current max to 1. And we also going to compare the new element with the smallest element. But out of these two elements, 2 is the smallest. So we keep smallest as it is. Then we move to next iteration. In next iteration, value of I becomes 2 and the element present at index 2 is 1. Okay. Again, we are going to find the difference between 1 and the smallest number. 1 minus 2 is minus 1. So this is not the maximum. So we keep our maximum current max as 1 itself. And then we are going to compare this new number with the smallest. 1 and 2. So out of 2 and 1, 1 is the smallest number. So we update our smallest to 1. And then we move to next iteration. In next iteration, our value of I becomes 3. And the element present at index 3 is 10. So again, we are going to calculate the difference. 10 minus 1 is 9. So this time we get the maximum difference. Before the maximum difference was 1 and now this time it is 9. So we update the current max to 9. And then we again compare this new element with the smallest element. And we see that the smallest among 1 and 10 is 1. So we keep the smallest as 1. And this loop is going to work for remaining elements for 5 and 4. But in case of 5 and 4, you will never going to get a maximum number greater than 9. So that is why the output of this input is going to be 9. So far so clear. Now talking about the time complexity of this function, here we are running only one loop n times. That is why the time complexity comes out to be big of n. And we can also say that theta of n also, because we are exactly running this loop for n times. And what about the space complexity? We are not using any extra space other than few variables and the input array. So the space complexity comes out to be theta of 1. So we are taking theta of n time and theta of 1 constant space to solve this problem using this efficient approach. Alright, I hope you got it. Now before we end this video, let's have a quick recap of what we have learned so far. So we are given a problem, and in this problem we are given an array and we have to find a pair with maximum difference in an array such that j is always going to greater than I, and we have to calculate difference by subtracting a of I from a of j. To solve this problem, we saw the brute force approach, and in this approach time complexity came out to be big of n square. And after brute force approach, we saw the efficient approach to solve this problem, and in this approach time complexity came out to be theta of n. And you can see that we have significantly reduced the time complexity from n square to n, because this is a quadratic order of growth and this is a linear order of growth. So I hope now you have good understanding of how to find a pair with maximum difference in an array. So this is it for this video. Thanks for watching and see you in the next video.